Hey guys, this is for a new series. I found this website called LeetCode that has a lot of programming challenges on it, similar to the Edit series that I did. This one sounded popular, so I thought I'd give it a go for either instructional purposes for people watching and also for my own entertainment. So, with that said, this was the very first problem I ran into on the list of problems when I clicked that tab. This one was in the easy category. I figured I'd start with the easy ones and then just progressively get harder. So without further ado, we'll get into it. This one is called toSum. You are given an array of integers. You are to return the indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So refer to the example. They give us this array of four integers, 2, 7, 11, and 15. The target value is 9. And since the first and second values add up to 9, they're expecting us to return those indices used for the sum that equals the target. So I think that's clear. Hopefully you understood that. We'll get into it. You should definitely pause and do this yourself too before seeing my solution. So I'm going to use I'm going to use a nested for loop. 0 1. So this will iterate over the collection, the integer array of nums, gathering all values. And then for each one of those, I want an inner loop. I'm sorry. Well, okay, we'll do it this way, then I'll show you why this comes up a little short. So basically the same thing. It goes over all of the values. And then the problem with this, though, is that you're duplicating comparisons. So you can imagine in the first iteration you're getting 2 compared to itself, and they told you may not use the same element twice. So you can try to do something cutesy like this. If j equals I, then continue, and that will filter out using the same element twice. But you can do better than this. And then the main logic is going to be if nums I plus nums j is equal to the target, then you're good, right? Return int I and j. You can do that. And they guaranteed that we would have exactly one solution, but we do say we're returning an int array and should probably do that. We should never get here, so I'll just put a weird error value in there. I think this will work. And yeah, it was accepted, but let me show you why this is sloppy. I'm gonna help visualize how this thing iterates. I'm going to show you the values of I and j at each point in the loop. That's the right line. So let's run this just so you can see. Oh, okay, since we're short-circuiting because I had return, so let's do it this way. Int array result equals new int. We'll do that. And instead of just returning, we'll say result equals that. And return result. And this is just so you can see it going through all of the loops. in the worst case, you know, you might find the match at the very end. So this will let you see how the loops work. In case you can't visualize that, see how we had 0, 0, which is bad. You can't compare elements to themselves. 0, 1, 0, 2, 0, 3, okay. Then in the next loop, look at this, you got 1 and 0, which is the same thing you had up here, you know, 0 and 1. You know about addition, it doesn't matter the order of the operands, you get the same result. So this is just a wasted evaluation. So that's bad. I think a way to make this better then would be to say j is equal to I plus 1, right? It always starts one value past I. So I is 0 in the first loop, that's this 2. Then your inner loop is going to start immediately from 7, then it's going to go to 11, then 15. You get to the second iteration, I is going to be 1, which is going to grab this 7 value for I. And then j, you're automatically starting at 11, right? You took the 1 plus 1, the second index, index 2, I should say, which is the third element in the collection. But you see how it always starts 1 after. And then when you get to the third iteration, you're comparing with 15. And so just to visualize this, I'll run the same thing again. And now since we're starting 1 after I, this thing of checking that they're equal, trying to optimize isn't even necessary. So let's run this. And look at that, it's a lot shorter, our output, right? Even though we went through the whole collection, we'll return back to the short circuit kind of thing where we just exit once we get our result. But I just wanted you to show how the iterations look: 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, and 2, 3. You know, it's not duplicating comparisons, and it's not comparing the same index, the same element twice that they told us not to. So that's a lot better, and then we'll just put it back to returning that result once it finds it. We don't need to go all the way through. Return and I'll put back that error value. I think this is clear. You don't need this anymore. And we'll run it again to make sure I didn't make any mistakes. And yeah, accepted. And so we know we didn't do any excessive comparing. It doesn't matter in this small example, but you can imagine how that becomes really wasteful when these collections are large. So yeah, maybe you did it with nested loops. That's cool, that gets you the result. But yeah, always try to do better and not be wasteful with resources if you can avoid it. So I'll submit that, I think. And thanks for watching. Feel free, you know, if you had your own solution, to share that as well. I appreciate that.